In this video are the worked solutions for the two one-dimensional motion problems given in the previous video, and I'll work through them by explicitly stating each of the steps I take. So with this question, the first thing we need to do is to find out what we want from the question. So the question asks us a number of things. First, to determine an expression for the instantaneous speed of the object as a function of time. So we're looking for essentially translating that into a mathematical equation. We're looking for an expression for v as a function of t. The second part of the question asks us to find the value of the speed at 4 seconds. So again, mathematically, all we're looking for now is to substitute the value of t equals 4 into the equation from part A. And the third thing the question asks is, when is the speed 0? So translating that, we're looking for the point in time, or the time in seconds, when our equation from part A is equal to 0. And the second thing that we need to do is to look at what we've got. So the question gives us an expression for the distance of the object as a function of time with units. So it gives us that xt is equal to c times a plus bt squared, and I will just expand that out so that I can see the quadratic equation in full. And I'll also write down explicitly what the units of each of those parts are. Our third step then is to look at which equations or which tools we need to use to solve this. So we're given an expression for the distance as a function of time and asked to find the velocity. And we know that the velocity is equal to the derivative of the distance. So we differentiate the distance with respect to time. Part 4 is the method that we'll use. So explicitly the order in which we'll do things. So for part A, we'll differentiate our xt equation. For part B, we'll substitute t equals 4 into the result from part A. And for part C, we'll set the equation we found in part A to 0, and we'll solve that for the t. And then to solve it, so step A is a simple differential. Differentiating cb times t squared becomes 2cb times t, and I've included the units in here. So in this case, it's meters per second, which is good because that agrees with the fact that we think we're finding a speed. In part B, I substitute in t equals 4 to find the solution. And in part C, we set our equation to 0. And we find that the speed of the leaf is 0 meters per second at the time t equals 0. The second question is a non-standard question in the sense that it's not obvious from the outset that we're talking about equations of motion. So step 1 is to look at what we want, and we're asked to find the rate at which the area of the leaf is vanishing. So we're asked to find an expression for the change in the area as a function of time. So that's a differential. What we've been given, so we've been given a few pieces of information. We know it's a circular leaf, and we know that the radius of this leaf is decreasing at a speed of v. So we need to note here that our direction of change is negative. Step 3 is to look at what equations we have. So we're dealing with a circular leaf and we're looking for the area. So we know that the equation for the area is equal to pi r squared. And we're looking for the rate at which the area is changing, which we don't have, but we do have the rate of change of the radius, somewhat indirectly. So we're told that the caterpillars advance at a speed of v inwards. So that means that the radius of the leaf is changing at a rate of v meters per second. So dr dt is equal to v. And we need to also remember that the radius is decreasing, so we make that a negative. Step 4 is to find the method. So the method that we use is we need to differentiate the equation for the leaf area to give us the change in area as a function of time. And we need to substitute in then the formula for dr dt to give us the answer in terms of the variables we have. So step 5 is to solve. So our area is equal to pi times r squared, and we know that the thing that's changing is the radius. So dA dt is equal to d dt of pi times r squared. Because we have two quantities that we can differentiate with respect to time, we use the chain rule of differentiation. And that gives us the following equation. So we have pi times dr dt times r plus pi times r times dr dt. So we have that dA dt is equal to 2 pi times r times dr dt. And into that equation, we then substitute in our rate of change of radius, that dr dt is equal to minus v, and we find that the rate that the area of the leaf is vanishing is at minus 2r times pi times v.